Today we delve into the incredible world of Martian rovers. What did they teach us about Mars? Were they of any good use? Let's embark on this journey to the Red Planet through the eyes of these intrepid explorers. The Martian rovers, a series of automated motor vehicles, were dispatched to the Red Planet with a purpose as vast as the cosmos itself. They were our proxies, our surrogates, sent on a mission of discovery and exploration. Their goal? To understand Mars's geology, climate, and to investigate the possibility of past life. Could Mars have once been a cradle for life? Can it support life in the future? These are questions that have captured human curiosity for centuries. From the first successful landing by Mars Pathfinder and its rover Sojourner in 1997 to the most recent missions of Perseverance and Ingenuity, we've sent a total of 5 rovers to Mars, each with a unique mission, and each contributing a different piece to the puzzle that is Mars. Sojourner, the pioneer, tested the waters, proving that roving Mars was possible. Spirit and Opportunity, the twin rovers, followed, with missions lasting far beyond their expected lifetimes. They provided us with our first real insight into the planet's geology and weather. Then came Curiosity, armed with an onboard laboratory, drilling into Martian rocks and analyzing their composition. And now we have Perseverance, the most advanced rover yet, capable of collecting and storing Martian rock samples for future retrieval. Alongside it, Ingenuity, the first helicopter on another planet, is proving that powered flight in Mars's thin atmosphere is possible. Each of these rovers played a crucial role in our understanding of Mars. They have, quite literally, changed the way we see our neighboring planet, from revealing evidence of ancient flowing water to detecting the key ingredients necessary for life as we know it. These Martian rovers have been of monumental use. So, were the Martian rovers of any good use? Absolutely. They've been invaluable in our quest to understand Mars, and by extension, our place in the cosmos. Now let's dive into the data these rovers have sent back to us. One of the key findings from the Martian rovers is understanding the geology of Mars. Let's delve into the planet's rocky layers, shall we? We'll start with Spirit, the rover that landed in Gusev Crater, a basin roughly the size of Connecticut. Spirit discovered rocks rich in olivine, a mineral that forms in magma. This suggests that there was once active volcanism on Mars. Next on our journey, we meet Opportunity, the rover that landed on the opposite side of Mars, in the Meridiani Planum. Here, Opportunity found evidence of past water activity in the form of hematite, a mineral that typically forms in water. This was a monumental discovery that pointed to a time when Mars was wet and potentially habitable. Now, let's speed up to the Gale Crater, where the Curiosity rover has been exploring since 2012. Curiosity discovered clay minerals in the crater's sedimentary rocks. Clay forms in the presence of water, reinforcing the idea that Mars was once a wet planet. But Curiosity didn't stop there. It also found sulfur, nitrogen, oxygen, phosphorus, and carbon, the key ingredients for life, in the Martian soil. Speaking of soil, it's a rusty red color, right? That's because Mars's surface is rich in iron oxide, more commonly known as rust. It's the same stuff that forms when iron is exposed to oxygen and water here on Earth. This rusty dust covers the entire Martian surface and even colors the sky pink during sunsets. But it's not all about what's on the surface. In 2018, the InSight lander detected seismic activity or Marsquakes, suggesting that Mars is not a geologically dead planet. It's still rumbling, still changing, still alive in its own way. So, the rovers have painted a vivid picture of Mars geology, but what about its atmospheric conditions? Another significant contribution of the Martian rovers is the data about the Martian atmosphere. Let's delve into this fascinating world of alien air, shall we? The Martian atmosphere is predominantly composed of carbon dioxide, with traces of nitrogen and argon. It's a stark contrast to our own atmosphere, with its life-giving oxygen and nitrogen. This difference is a fundamental barrier to human habitation, but it also presents intriguing possibilities for studying an entirely different planetary system. Temperature is another key aspect of the Martian atmosphere. It's a chilly place, with average temperatures hovering around -80 degrees Fahrenheit. However, don't let that fool you into thinking Mars is a frozen wasteland. The red planet can experience wide temperature fluctuations, from -195 degrees Fahrenheit during polar nights to a balmy 70 degrees Fahrenheit at the equator during summer. These extremes are largely due to the thinness of the Martian atmosphere, which is less than 1% the pressure of Earth's at sea level. The Martian rovers, like Perseverance and Curiosity, have been instrumental in collecting this data. They've been our remote weather stations, tirelessly recording temperature, pressure, and wind speed. Their observations have allowed us to map out Mars' weather patterns, revealing a world of dust storms and thin, wispy clouds of carbon dioxide. But it's not just about recording data. These rovers have also been testing theories. For instance, the discovery of methane in the Martian atmosphere by Curiosity sparked a lot of excitement. On Earth, methane is primarily produced by biological processes, leading some to speculate about the possibility of microbial life on Mars. While no consensus has been reached on the methane's origin, it's an excellent example of how these rovers are pushing the boundaries of our knowledge. These rovers have provided invaluable data about the Martian atmosphere. But what about the potential for life? Let's take a closer look at what these Martian explorers have uncovered in our next segment. One of the most exciting questions these rovers aim to answer is whether Mars could have supported life. The exploration of Mars by rovers like Curiosity and Perseverance has yielded some tantalizing clues. Curiosity, for instance, made a monumental discovery in 2018. It found organic molecules in a 3-billion-year-old mudstone in Mars' Gale crater. Organic molecules are the building blocks of life as we know it, and finding them on Mars was a game-changer. These molecules, although not definitive proof of life, certainly suggest that the conditions necessary for life may have once existed on Mars. But the intrigue doesn't stop there. Curiosity also detected methane in the Martian atmosphere. Now, methane can be produced by geological processes, but on Earth, the vast majority of methane is produced by living organisms. So, could Mars methane hint at a biological origin? We don't know yet, but the possibility is certainly intriguing. Then there's Perseverance, which landed on Mars in early 2021. It's tasked with seeking signs of ancient life and collecting rock and soil samples for future return to Earth. Perseverance has been exploring Jezero crater, an ancient lake bed. Scientists believe that if life ever existed on Mars, it would have been in places like Jezero. In February 2022, Perseverance made a significant discovery. It found that rocks in the crater were clearly laid down in the presence of water, and that they contain clay minerals. These clay minerals can trap and preserve organic molecules, which could be signs of past life. These findings, while not definitive proof of life, are incredibly promising. They suggest that Mars, at least in the past, had conditions that could have supported life. And they point us in the direction we need to go to answer the question, did life ever exist on Mars? These discoveries have opened up a whole new realm of possibilities for life beyond Earth. So, were these Martian rovers of any good use? Indeed they were. The Martian rovers have been instrumental in painting a vivid picture of the red planet's past and present. Their findings have fundamentally reshaped our understanding of Mars, revealing a world far more complex and intriguing than we could have ever imagined. The rovers have unearthed evidence of ancient water bodies, hinting at a distant past where Mars may have hosted life. These discoveries have not only unveiled Mars' geological history, but have also fueled our quest to answer the timeless question, are we alone in the universe? Furthermore, these robotic explorers have provided invaluable data about Martian weather, atmospheric composition, and radiation levels. This information is crucial for planning future human missions to Mars. By giving us a glimpse into the challenges astronauts might face, the rovers have helped us prepare for the day when we'll set foot on Martian soil. But perhaps the most significant impact of the Martian rovers is how they've ignited our curiosity and broadened our horizons. They've inspired millions around the world to look up at the night sky with wonder, sparking a renewed interest in space exploration. Indeed, the Martian rovers have revolutionized our understanding of Mars and paved the way for future exploration. Their legacy will live on, guiding our steps as we journey further into the cosmos.